Notes 12, page 3. This is our last big topic, and it's a big one. Rational expressions, essentially fractions. Okay, so we are going to learn to reduce rational expressions, multiply, divide, add, subtract. Deal a little bit with compound fractions. So there is one big idea that you need to remember when reducing fractions and also when multiplying and dividing is this one right here. We can cancel identical or sometimes opposite factors to reduce a fraction, but we cannot cancel terms, or what some people try to do, they try to cancel part of a term when reducing. You can't do it. Why not? Well, if you try canceling a term, you do not get an equivalent expression. You change the value of the expression. Why is it we can cancel identical or opposite factors? Well, it's essentially because multiplying by 1 doesn't change the value of an expression. What's 5 times 1? It's still 5. What's 7 times 1? It's still 7. So, let's look at an expression like this. Here's a fraction. And remember, if there's no coefficient in the denominator, we can think of that as 1 times the quantity x plus 1. So x plus 1 is a factor of the numerator, and x plus 1 is a factor of the denominator. And we could actually sort of peel the x plus 1 factors into its own little fraction. So this is the same as 2 over 1 times x plus 1 over x plus 1. But a number divided by itself is always 1. So that's going to reduce to 1. We say it cancels. We cancel the identical factors, and you're just left with 2. Now, there's one little caveat here. So we have to be careful. I want this expression, my original expression, I want this equals to be true, that the answer will always be 2. So let's plug in a few values. I'm going to plug in 0 here and here, and that leaves me with 1 over 1. Yeah, that equals 2. I'm going to plug in -3 for x. Well, -3 plus 1 is -2. Yeah, -2 over 2. That reduces to 1. Yep, you get 2. I'm going to plug in 5 for x. Well, 5 plus 1 is 6. That gives me 6 over 6. Yeah, that's 2. Now, I'm going to plug in -1 for x. If I plug in -1, I get 0 over 0, which is meaningless. That got cut off a little bit because the denominator was 0. So when I plug in -1, when x equals -1, I got a little sloppy there, 2 over x plus 1 over x plus 1 is not going to equal 2. So this equals that I'm saying holds really doesn't hold. So I don't want to lie to anybody ever. So I'm going to tell people, hey, you know, these two expressions will be equal as long as you don't pick -1 for x. And that's the only restriction that we're going to have on x. We call it a restriction because we have to restrict our choice for x. Because hopefully you can see putting in -1 for x is the only value that would cause us to divide by 0. So what we're going to say when we reduce something like this is 2 times the quantity x plus 1 over x plus 1 will equal 2 for all values of x except -1. If you plug in -1, this equals will not be true. Any other number, it's going to work. We call -1 the restriction on x. And then we have sort of the different point of view, which is going to be really important. We would say the domain of the expression 2 over x plus 1, 2 times x plus 1 over x plus 1, is any real number except negative 1. Now, that's because if you plug in any real number for x, I mean, it could be pi, it could be negative 1,000,000, this will wind up being defined and it will equal 2. But if you plug in negative 1, this expression has no meaning. So we say negative 1 is not in the domain. The domain is what you're allowed to pick for x. So, 2 new words here. The restriction on x is what you are not allowed to pick for x. The domain of the expression is the list of real numbers you are allowed to pick for x. Now, a little concept question here. Now evaluate this expression if x is 29 over 37. And do it in your head. Okay. Well, hopefully you realized what this equals up here means. This expression will equal 2 no matter what you plug in for x, except for negative 1. So it's going to equal 2 for 29/37ths. I would actually never make you do that gross arithmetic on a test or a quiz or anything like that. Just be like, this is a thought question. All right. Now, this got cut off a little bit, but there's a little thought here I want to add. Negative 7 and 7, so negative 7 over 7, those are opposites. And we can see them as factors because we can always think of this as times 1. So negative 7 and 7, they're opposite factors. But when you reduce that, you get negative 1. Okay? So what we see is opposite factors cancel to a factor of negative 1. Okay? Now, another little pattern you want to check out. 3 minus 8, 8 minus 3. Notice how I have flipped the numbers around the subtraction sign. And subtraction is not commutative. These answers are not the same. 3 minus 8 is negative 5, and 8 minus 3 is 5. Notice how the answers are opposites. Anytime you flip two numbers around the minus sign, you get opposites for answers. Give it a try. Try a couple of different numbers. So this again, because they're opposite factors, will reduce to negative 1. Now, noticing this pattern can help you have a little few shortcuts when you're working with reducing fractions. Now, it's a little hard to see. Mine got cut off a little bit. This is 2 minus x over x minus 2. Now, these are going to be opposites. See how I flipped the numbers around the sign, minus sign? So I'm going to go up here. If I made x 6, this would be 2 minus 6 over 6 minus 2. Oh, that would be negative 4 over 4. That's going to be negative 1. If x was 7, that'd be 2 minus 7 over 7 minus 2. That's going to be opposites. It's going to be negative 1. So without doing any work, hopefully you can see that this ought to reduce to negative 1. Now I'll show you all the little algebra that can show you that. Remember we talked about factoring out a negative 1 as a GCF. I'm going to do that in the numerator. If I factor out negative 1 in the GCF, then negative 1 times what would give me 2? That would be negative 2. I'm just going to put it in the back. Negative 1 times what would give me negative x? That'd be positive x. Now on the bottom, I can think of this as 1 times x minus 2. And by the way, check this out. This is a sneaky little thing that you need to learn to do. X and 2 are terms. You cannot cancel terms. You can only cancel factors when reducing a fraction. Well, that's prime. How can I factor it? Well, here's the sneaky little thing you do. You scoop it in parentheses, think of it as 1 times that, and voila, x minus 2 is now your factor. So x minus 2 over x minus 2 here, those are identical factors, and there it is, cancels to -1. But if you recognize the flipping around the minus sign, then you can say, oh, those are opposite factors, those will cancel to -1. You don't have to show that step. Now, one last thing I want to add to this. This expression is going to equal -1 for any number you plug in for x, except what? Look at that denominator. What value for x would make that 0? 2. It's going to equal -1 as long as you don't plug in 2 for x. That's the restriction. If you plug in 2 for x, this expression is meaningless, which is not the same as -1. All right, so we're going to continue on with this idea on the next video.